Good.
So I'm Alan Reese. This is Jack Weaver. We're going to talk about DevOps, how we do it at Yahoo, and how people at startups can do it. First, I'll talk about DevOps at Yahoo and how we go about doing it. Then Jack will talk about SADA, and then we'll go over an example of how you can do things yourself. I work for Yahoo. I've been in JNI. I've been there for 10 years. I write lots of JNI. I moved Yahoo's products and core libraries from RHEL 4 to RHEL 6, now to RHEL 7. I go around building everyone else's packages. It's either Java, it's C++, it's RPMs. So I get to deal with our build systems a lot.
My name is Jack Weaver. I work at a much smaller company called SADA Systems. I used to work with Alan at Yahoo. So we're in kind of a unique situation now to talk about DevOps and how we've experienced it both at a large organization like Yahoo with thousands of engineers, massive build farms, the whole 9 yards, and then going to a company like SADA, which had zero experience in DevOps, starting from square one, right? Small teams, low budgets, and then to be able to kind of compare and contrast those two. And DevOps is a big topic. So, we're going to cover a few points here. One of the things I really love about this conference is that we'll be out there, we'll be, in other conferences and other talks, we'll be having dinner. By all means, come up to us and talk to us if you ever have questions in and out or you see us out and about. Because like I said, we have a limited time here to talk about only a few sub-slices of what DevOps is and how we've approached it at two different organizations, large and small. All code and demos, we have links for all of this. So if you want to follow along, check out, I would just run to that bit.ly link if you want. There's a PDF export of all the slides. We have code. There's a number of code repos that we've built and kind of thrown code up there for. By all means, take it, play with it, test it out for yourself, see where it might work out well for you, might not work. This is by no means the end-all be-all. There's a lot of ways to do automation, deployments, testing, pipelines. This is just one approach, and it's a fairly lightweight sort of approach using Docker and Kubernetes, and we'll get into some of the details there. We have an Artifactory instance, and if you're curious about the Travis builds, they're there as well. So quick note on SADA. It's a small company, about 150 employees, maybe 25 or so engineers. I'm the tech lead on a product called Atom. It's a brand new greenfield SaaS multi-tenant application, no legacy code having to deal with that. That's a big advantage over bigger companies like Yahoo. They have a lot of legacy systems. I don't have to deal with any of that. Originally, when I first got there, it was literally zero DevOps. There was nothing. And I'm not ashamed to talk about this because we've grown tremendously now. In just 12 months, it's been a heck of a ride. But first days I'm there and there's engineers like doing live deployments from their dev box. Like, yeah, I'm pushing code to production. It's like, okay, do you have a Git tag at least for that? Testing was literally someone just clicking around. Very little unit tests. Medical science can't really explain why that person's still alive. Things are different now. We have a lot of automation, a lot of unit tests, a lot of gated sort of controls in place. And it's been a shift in culture. Some of the original engineers that were there, they've gone from this mindset of being kind of cowboy codey, just shooting from the hip, to a little bit more standard process, standard procedure, and the culture is entirely different now. So it's, DevOps is interesting because you not only look at the tools and the processes, but you have to look at your culture, and you have to look at the engineers that you have on your team and make sure that everybody's on the same page and that they believe in what you're doing. A lot of people haven't seen this stuff, don't understand it, and they don't think there's a lot of value in it. So you have to convince them. And I came from an organization at Yahoo where we lived and breathed DevOps, and we had tons of automation in place. And then I came to a company that had never seen it before. And so there's a lot of challenges there. And you have to be able to speak in terms of ROI and a number of things to convince folks. And then after they see it, right, it starts clicking, and they become believers, okay? They convert. So there's a few principles you got to kind of start off with. Right off the bat, you have to recognize that development is an economic activity. What we do is all about really the economies of time. You have to look at how you're doing your DevOps, your automation, your CI/CD, and value it in terms of an ROI. And what this means is that you might not build a lot of big systems in the beginning. It doesn't make sense. Your ROI might be small on that. So you have to start small, pick something very small, and then build from there and build from there. We started and progressed outwards. You know, we use a lot of SaaS tooling because there's like 5 engineers on the team. So we can't build and manage like big Jenkins systems or anything like that. We actually use Travis. We use GitHub. We use a number of different tools around that. And by no means are these tools the ones that you should go with. Look at the different providers and evaluate it for you if you're small. If you're big, you can still evaluate them, but you might find that you're better off in more of a Yahoo world where you own your Jenkins systems, you manage them yourself, and that's actually the better fit for you.
You want to make sure that tools that you pick fit your existing culture, your existing setup, the things you're already doing. If you're a big operation, look at what you're already doing and apply principles. If you're small, look at the tooling. Hey, can I use this? Will it make me work better? Will it make me work faster?
Yeah, everything is about ROI and being able to kind of internalize that savings in terms of time and then sell it, right? So I'll walk through kind of a basic sort of automation pipeline. We're not, kind of reinventing the wheel here. There's a couple of interesting parts, and there's a number of different Travis jobs and how you think about your code repos. I've separated services or service repos separate from repos that manage deployment. Quick show of hands, how many folks use Docker or Kubernetes? Okay. So in my services, in my repos, because I have a stack that's run on Kubernetes and Google Container Engine, or GKE, the service repos, so foo, bar, baz, whatever they may be, those only produce a Docker image, nothing else. Right? They don't know about Kubernetes. I have a separate repository that actually keeps Kubernetes configurations. And this gives you a few advantages. You don't have to intermingle these concerns, right? I view them as separate concerns, and I handle them separately.
It also allows your developers to pull the same Docker containers and play with them outside your deployment pipeline. If you get your deployment pipeline too crazy, you might have problems debugging it.
So you're going to do a pull request. You're going to send it to your foo service or whatever you have. That's going to, after it gets merged, it's going to trigger a build. Again, I got Travis. You could use Circle, Semaphore, Drone, evaluate them, figure out what's good for you. When it's done, it's going to push a Docker image out to Artifactory. It will push a new version or a new label. Okay, it's going to say, hey, here's, we ran it, we built it. I've got unit tests that run. I actually stand up that Docker image, and I can run basic sort of API tests against it. One of the other tenets that we use back at SADA is all the services have a spec. So I use OpenAPI spec or Swagger. All of these things are documented. They're contracts. So I know what to test against. After it's pushed, Travis is now going to do something special. It's going to make a commit for us in a separate repository. That separate repository contains Kubernetes configurations. So I have a deployment YAML file in there. All I have to really do is just make a commit into that repository and say, hey, here's a brand new image, here's the tag, I just pushed it so I know what it is. And it passed that first sort of stage of testing, right? And now I want to send it out, I want to deploy it. So Travis makes that commit. That kicks off a brand new job, a separate Travis job. And that one is now responsible for conducting a rolling update. And once it's deployed in your environment, it could be dev, it could be however you want to wire this up, right? It's totally up to you. I've called it dev here just for sake of argument. It'll roll it out. It'll run a bunch of tests against it because, again, it has better understanding at that level of what your topology looks like. Maybe it's going to run some tests from a service that relies on this one. And you can actually hit different APIs and get data flowing through and ensure that nothing's really broken after it's delivered into the environment. As much as we like to think that code is completely decoupled and services are decoupled, that's not reality. Things get messy. You might find services relying on other services. So again, this is another point in time to run tests. Assuming those pass, you're going to then update the label on Artifactory for that container. You're going to say, hey, it's passed. I'll make a REST API call up to Artifactory, or you could probably use JFrog CLI, however you want to manage it, and apply this label. And that label on that container is going to tell you that it's now good for that environment. If it's dev, it's dev. If it's prod, it's prod. And if you set up multiple environments, not everything will make it through all the way. Like this might not make it out to prod, right? You want to be able to go back later and identify what you've actually deployed. So if you have 5 or 6 or 10 different services, you can lean on labels or properties inside of Artifactory to help provide that for you.
Well, you can also use those to clean up. And that's the biggest mistake a lot of bigger people make is storage is free. I have as many of these as I want.
And once that's done, this is kind of like extra credit. So let's say you have a big Kubernetes cluster, and you've got 15 or 20 different services, and you're running maybe multiple environments. Maybe there's a dev, maybe there's a prod. You've decided for whatever your industry is in your use case that you want little islands of environments, and then you want to do gated releases from like one to another. This is one way you can do that. There's a bunch of different ways. This is like the lowest, I'll say, low friction solution that we've come up with. And again, five engineers starting from scratch, and they've had to kind of come along with this and learn it, and it was the easiest way to do it at the time. But you can actually write into a separate repository what you have deployed. And you can update a file to show that, hey, I have this pod and these images inside of it, and this is the environment it's on. So if I have dev, I could pull up that little JSON file and see that foo is at 123 and bar is at 103. And then I could switch branches in that same repo to, say, my prod. And then I could see that same file, except with the prod versions. The other thing you can do is you can actually hook a Travis job up to this file, right, this repo. So now it allows you to pull requests from one repo, dev branch, same repo, dev branch into prod or QA or wherever you want to go. And after you merge it, Travis can then, or Circle, again, whatever your CI is, can then go to all of the other service repos, okay, check out the branch that you want to be on, and then make a commit. So in foo Kubernetes configuration, those have branches. It's not master. It's not feature branches or anything like that. The branches there are named after the environments that they apply to. And so if you just change that version, what is that Travis job going to do? It's going to do a whole new deployment to that environment. And so this third repository, this environments repository, if you will, allows you to do that. It's a way of kind of doing really nice gated releases from one to another.
That setup also allows you to have neat little hooks. You can post to Slack, you can post to HipChat, whatever you want. Because since you already have a job that's doing, I'm moving from stage to prod, you can all of a sudden say, hey, I can update Jira's. What changed? I can update Slack so people know, hey, it's going to break.
And the other thing is that this scales with team. So a lot of times you might find that you have component owners or developers who are really good at whatever service it is. They wrote service foo, they know it inside and out. If you're doing a prod release, you could say, hey, here's one simple file to look and see what services are changing from one environment to another, right? It'll show you the diff inside GitHub or whatever you're using. And then you can get them to sign off on it and say, yes, this works, it's good, right? You get everybody to give that thumbs up before you click that merge button and then do a mass sort of rollout.
It also helps your postmortems.
So we talked a little bit about this. I like to call some of these different jobs articulation points. When you think about it, if you separate concerns by code and by job, you get different areas in your pipeline to kind of make little tweaks and configurations. You can start small on something like this, and then you can really throw more advanced testing and automation on top of it. So we use Slack, you could use HipChat, you could use whatever you want, and we get automatic notifications from the integration there that a deployment goes out. So I might be working on a service, and my neighbor on a different service does an update or something like that, and then all of a sudden I get a notification in Slack that he just pushed a new version. I might have been waiting on that, right? And it facilitates that level of communication. Like you want people to communicate well. This is really low friction, asynchronous level communication to do it.
So now, after he's told you about all the stuff that they do there, I'm going to tell you what we do at Yahoo. We have a giant DevTools team. I have, 60, 80 people. They built us a custom CD solution. We have another team that built us a custom cloud solution. Tons of code, custom code. I want to set up a new job. I make a 10-line YAML file. I commit it. I go hit a URL. I'm done. My stuff's going out to production. That's it. But I got 60 people to do it. We own data centers. We don't have many clouds. We don't have cost controls. We don't have restrictions. Those can be problems. That's something you need to think about when you're little is, hey, maybe a NAS file holding all of my stuff isn't going to scale. It costs money to run things. We keep data forever until we have a problem. We once had a problem where we accidentally deleted things we probably shouldn't have. It's something you learn. We control every aspect of what is run and deployed. We have guidelines that you follow these guidelines, your life is going to be easy. You don't, not only will your life be hard, but you can't get the rest of the engineers to help you out, and so you're better off doing what everyone else is doing. It makes it interesting because all of a sudden, everyone's builds look the same. That's why I can go around and build everyone else's packages for a new operating system. Because politically, we've forced everyone to do it the same way. Not only because it's easy, but also because we embarrass them by saying, hey man, it took me forever to fix your stuff. That's one key takeaway. The more your builds look the same, the easier it is to do interesting things. You shouldn't be spending time figuring out what your build does. We have tons of custom monitoring and CI tools. They're mostly built around Jenkins. That can be a good thing, can be a bad thing. Some of the choices we made led us down a path that meant the way we were using Jenkins wasn't scalable. I don't think anyone here should hit the problems we've done. One of our issues that we've also had is one big box fits it all. We put everything in the same GitHub repo. We have not one, not two, but probably 3 to 5 of the largest Jenkins farms in the world. We put as many jobs on that as we can. We do something about, 100,000, 200,000 builds a day across 2 different CI platforms. One is just pure Jenkins, and it's a pain for me to fix. The other one's our custom internal one, which works really well, but it has other interesting quirks. We have a completely different internal SaaS platform that if you use it, it's really easy to use, and you just push your jar and you're done. Our product teams make their own choices about the builds. So we have the guys who've been using Jenkins for the past 10 years, and those builds, you can tell they've been around for 10 years. They've got all sorts of custom hooks. And one thing we found with that is that the more configuration you put into Jenkins, and the newer Jenkins, you'll see that this has gone away. They've done things to help you stop putting configuration in Jenkins. The harder it is to replicate and debug. With our shared build platforms, it's a YAML file that says, hey, I'm using CPP platform. I'm building on Rails 6 and Rails 7. Email me when it fails. That's it. The less code you put in your build configuration and your build pipeline, the easier it is for your developers to debug it. The other problem with shared infrastructure is it's a shared outage. So, we have a big problem, nobody can build. Well, that's cool, but now we're losing money because we need to do an ad server release, and we got to wait till the build system's fixed. Also means shared security holes. Your builds typically need a couple of secrets. When you share that across 10, 100 product teams, now anyone can go extract those secrets and either use them for malicious intent because it's a hacker on your network, or use them for things that they weren't meant to be used for. All of your source effectively becomes public. Sometimes you have pieces of source that it's kind of critical that other people do not have access to it. Maybe it's like, a search algorithm or ad quality algorithm. When you start sharing build infrastructure, all of a sudden, because your CI jobs can check the build out, anyone can see the source. Resource constraints. So our build system uses Docker extensively, and one of the problems you have with Jenkins and executors is one job can run make-j and completely monopolize that executor, much to everyone else's chagrin and pain. So we decided, hey, we're going to use Docker. We're going to limit your memory. You get 2 gigabytes. All of a sudden, every single Java build started failing mysteriously. All of them. OOM killer every day. Well, why does anyone set their heap? Well, I set my heap for Maven, not for Surefire, not for Surefire failsafe, not for all the other Java JVMs it runs. The interesting thing about this is it was actually C groups breaking the JDK. JDK has had no idea of this. If you get 8U131, there's an experimental option. You can say, hey, go look at C groups for enable experimental options, and then enable C groups for heaps. So it'll do ergonomics based on the memory size it sees for the Docker container. Without that flag, it'll still do ergonomics based on the number of CPUs. Problem with this is you're running Java. So now you got to either get everyone to know about those 2 flags, which is kind of a pain, or you replace their Java binary to say, hey, am I a Docker? Yes, I am. Let me turn these flags on. Hopefully in the future, Oracle's going to fix that, and they know about this. They're going to make it better and try and get it automatic.
So, there's a question, because there's a big gulp or gap, okay, between what large organizations are able to do. I mean, with 5 engineers, clearly I'm not running 200,000 builds a day, okay, and I don't need the world's largest Jenkins cluster. So, just a tip, take it from someone who's had to work in a really small, tightly constrained environment. Rely on that SaaS tooling as much as you can. We live in an amazing time right now, okay? Software's eating the world. There's developers, doing really amazing things out there. And we're now getting really cool automation and SaaS products that are being developed that help us build our software faster and better. So lean on that as much as you can. This is just a list of things that, we're a Google shop, so we use the full GCP stack. You could use AWS, it doesn't matter. I don't touch much on the monitoring and the alerting aspect in this deck, but we use Stackdriver. We have monitors and alerts all the way from the individual components in our system. If I have a GCE instance that's running Mongo, I can know certain aspects that is healthy, right? You set all of that up and use it, right? Trust it, use it.
The one thing we didn't cover here that we also do is cloud gives you fantastic elasticity. I own a data center. I have 100 machines sitting there. With hybrid cloud, I could say, hey, you know what? I know 100 machines usually covers it, but if I spike, I can spin up instances and I can run 1,000. There were times in my past that we had 1,000 machines sitting there idle for all of the year except for the Oscars or the Golden Globes or whatever award show, and those things would be at 100% CPU for that entire show. Nowadays, we have 100 machines and we spin up 900 right before the award show. That's something you can take advantage of. You're a small shop, you're doing little things, and then bam, you hit it big and you just start scaling out and you take advantage of that and then you pay the bills.
Yeah, and the flip side to this is because you're relying a lot more on, public SaaS tooling, public cloud. If those guys are down, you're down too. There's been a number of outages. Some have made headlines in the past. What amazes me is that a lot of these things are actually rooted back to human error. Like somebody was running a command and they fat-fingered it. And I'm sitting back thinking, like, why are they even doing that? Have a machine run it, review it, make sure it works, and use the machine to execute it. But their downtime is your downtime. So there is some risk there, and you got to kind of balance that with your cost, right? This is an ROI game. Like, if they're down, how much can we tolerate it? Are we in an industry where we can't tolerate any downtime? Are we in an industry where we can tolerate some? How often are they going to be down? What are their SLAs like? And go through that sort of rigor and that process to choose good tooling. The other thing is, going back to this, there is going to be some payment in terms of time that you're going to have to make. When you use these tools, you're going to have to write what I call glue code, right? It's basically code to make everything hook up and work well together. So I need a set of scripts. I need whatever it might be to run my builds and then push something to Artifactory or do a rolling update to Kubernetes, even make a commit into GitHub. There's a certain level of scripting and coding you're going to have to do. I think in larger organizations, to Alan's point, when you're sharing a lot of these build platforms that they make, I could be a new team within Yahoo and just pick it up and go.
Somebody else writes the glue code for you. That's me.
So externalize a lot of that, okay? Make it a package, push it to Artifactory, and then on all your Circle or Travis jobs or whatever infrastructure you're running, install it right off the beginning, right? Or, authenticate with Artifactory, pull it in and install it, and then share that code across all your SaaS CI builds.
We actually do that internally. So our build platform is actually literally a whole bunch of glue code packages. It's a Docker image with a bunch of glue code packages. You install what you need. We have a way to tell. I need these 9, 10, 15, 20 RPMs. And then my agreement with you is I'm going to run gmake platforms, test coverage platforms, package release, and whatever comes out, I'm going to upload to Artifactory.
And then, obviously a big advantage is if you're one of the really small organizations, you're not dealing with legacy. Architect your software and design to take into account the automation that you can use and the tooling and how that works. The systems that were built, 10 years ago did not know of Artifactory or the newer tech stack that's out there. You know about it now. You know what it's capable of. Build that into the overall design, and you'll find that things mesh a lot well, right? They just work.
The funny part is a lot of the older software had articulation points that somebody was thinking ahead, and because they did, I could at least shove a bottle of glue in there and make it go where it needs to go.
So kind of the last slide on this, and then we'll get into a little bit of some demo. Try to make things simple, understand how things work together, and lean on the tooling, test it, go through that full rigor. It does have an ROI and a benefit as time goes on, you experience it.
When somebody else shows you a cool tool, make sure you understand how they're using it. There's a group I worked with that said, hey, we want to build RPMs. That's great. So we're going to use Gradle to build our RPMs, because other people are using Gradle to build C++, and they're building RPMs. And what we did is we put Gradle inside of a build tool. So we have a build tool inside of a packaging tool. So we have a build tool that calls a packaging tool, that calls a build tool, that generates an RPM that actually sucked. Why? Because the people who made the plugin to build the RPM had a different use case in mind for that RPM. It was enough to make a package to put that RPM in a Docker file, actually in an AMI, and ship that AMI on down the road. They didn't care about traceability like we did. We didn't understand why somebody had written the tool. We didn't look at what they were doing. And it cost us some time that we shouldn't have spent. So why should you change what you were doing? So at one point in time at Yahoo, we started looking, we had lots of incidents. We started keeping better track of them. We decided, let's look and see what's causing these incidents. Number one cause was human error. They skipped the runbook. There was no runbook. They miskeyed it. They missed a step. There were too many steps. They forgot checks. People always, if I give you a list of text, we had an issue where everyone needs to run these 10 commands the other day. We have 8,000 VMs. Everyone owner of those VMs needs to run 10 commands. How many of you think that everyone ran all 10 commands? Okay, 50% of them ran them all. 1%. There were one or two guys who managed to run all 10 commands. So after a little bit of an escalation, everyone got a one-line command. You run this to do it, you run this to check it. We got 100% coverage after that. Every engineer deploys code differently. If you have engineers deploying code, you never know how it's going out. I myself have caused many interesting outages. One day at lunch, I decided, hey, you know what? This thing takes an hour and a half to load. I'm going to push it out across 40 machines. I get back from lunch with a very angry boss because I just taken down the entire cluster by pushing out the same piece of code because they all take a full hour to reload their database. I had no idea it was supposed to be staggered because nobody had told me. This same site, we have this 40-node cluster. There are actually 5 services. Each one uses the same Java code to run. I'm looking at one of them, and across the 40 machines, there are 38 different jars. I start taking these jars apart. There are 39 different jars. There are 38 different versions. They don't line up to source control at all. I start digging deeper. Every single one was a minimal modification across on a dev box of the code, and the 39th jar was the code that was in source control. I look at the next box, it's exactly a year younger. Turns out that they would commit, they would just push the jar to a machine in the cluster till they got it working everywhere, and then they'd start on the next one, breaking the previous cluster. It was kind of a mess.
So, here's a live demo. I'm going to run through just a brief overview of the components and how they're wired up. Like I said, all of this stuff is available on our GitHub repo, and we'll show those links again.
The GitHub repo is swampUP mere mortals. One thing we did is we set up Artifactory software as a service trial on GCP. It took me 30 seconds to do. It was really quick. You get a free 30-day trial. The prices are pretty competitive. It's a lot cheaper than setting up. We have 5 people to run Artifactory internally. We run 4 or 5 of them plus a giant CDN. It's a lot of work for a little person to just run Artifactory.
And a quick little pro tip, if you're using the SaaS version like I am at SADA, you can actually, in our case, we're GCP, you could actually stand this up in the same region that you're deployed in. So if you're starting out in US Central 1, you can actually stand up GCP inside of Iowa, and it helps a little bit.
Then for Gradle, Maven, Docker, there are JFrog dev/project examples are complicated examples there for all the use cases for pushing to Artifactory, tagging builds, pulling from it. All this code was based off their examples. I don't know, we put it together in what, a week or two?
Yeah, it didn't take too long. It was fairly straightforward. So a couple things, there's a lot of repos here. Remember, I've separated things into kind of service repos that produce Docker images, and then separate repos that have Kubernetes information, like this deployment YAML file.
Might make it bigger.
And again, this actually has this Docker image with a label on it, so it knows exactly what to kind of pull and look for. And what I'm going to show is that after I do a deployment, I have my robot, okay, my mere mortal CI, this little guy here. He actually makes a commit and he updates that version, 126 in this case. And we can pull up his page and you can see he's been making commits, right?
He needs some followers.
So real quick, let's go to one of my services, and I have a PR that I opened earlier. So I'm changing some really simple stuff here. Every single request got a 500. I'm saying this, this isn't
I don't make bugs, do I?
We're not throwing 500s all the time. So let's wrap it in oops, and let's only throw 500 when oops happens. So Alan approved it. I'm going to go ahead and merge it. Now the builds take a little while. You got to remember, we're kind of in the open source using free stuff. So this is going to trigger a build. I'll clean up my branch. And when Travis picks up that change,
you'll actually see this even on our internal stuff. Sometimes it can take 15, 20 minutes.
While that's kind of warming up and it's going to kick off here in a little bit, let's talk about some of the other repos. So keep in mind, the only goal here with Crispy Barnacle is to produce a Docker image. That's it. So there's a Docker file. I have my Travis file. And if you actually look how CI is configured, there's quite a bit going on here. I have to authenticate with a token into GitHub. So I had to set that up as part of the Travis job. I have to authenticate with Artifactory. So I'm passing in this case, the username and password, because what I want to do.
API key. You always use an API key and not a password when talking to Artifactory, because API keys can be revoked.
And I want to echo out into my sources because I want to install a Debian package. So if I toggle over to my Artifactory instance, you'll see there's a few different packages here. There's Docker. Here's Debian. I have a nice little package in here that has a bunch of scripts in it, CI scripts. And I install this across all my builds. So I have one place to go to anytime I need to change a lot of these scripts. Because imagine having 10 of these different services, right? They're all going to be pretty much doing the same thing. There might be some tweaks here and there. You can change the service code here or the CI code, and then just have this produce a new package and just install that from your jobs. And then, of course, a Docker repository. I only have 2 services. Crispy is the only one that's actually doing any deployments. We're up to 126, and this was earlier today, about an hour ago. I pushed it. I wanted to make sure that things run. And then after that, there's a line to actually install the scripts. I have to say force yes. This is a hack. By all means, sign your packages and make sure that the actual job that's running it is aware. And you won't have to run that. And then the actual code itself, I make sure that it's not a pull request. And if it's not, I go ahead and I publish the Docker image, right? I make a commit into that deployment repository because I want to update my Kubernetes with the latest image that I just pushed.
So we're cloning the repo, going into the repo, setting up GitHub to be able to have the right credentials to commit. And this actually turned out to be a little more complicated than it seemed like it should have been.
Keep in mind that this is just something that we threw together. You're going to clean this up, right? If you want to take the same approach, have better code, clean it up a little bit more. I mean, we went, crazy over like a few days and just started throwing stuff.
This whole block should have been a shell script. Like, it should have been a CI script. Hey, commit. If it's a pull request, commit.
And then lastly, the very last thing it'll automatically bump our version for us. So if we just ran our code, we produced a brand new, version, then, bump it.
Gradle, that was easy. It was change one line in a properties file. With Maven, there's a reason it's a script. It can get kind of complicated. There are actually Maven and Gradle examples in these repos if you want to see it. We made it work with both, and we even stamped the properties in Artifactory on the jars.
So this created Crispy Barnacle 127. And what it's going to do is go ahead and push that up into Artifactory. And when it's complete, we'll see a brand new version here. Should be pretty close. And the nice thing is, again, you could pull these images. So if you're on a team that has a lot of different services, you could use this to trigger a Slack notification or a HipChat notification and say, hey, brand new version. And if I'm another guy that's on the team that's going to use 127, and I know that they're working on this because we're in a sprint and we have tickets and we know what we're working on and what we're waiting on, I might have a dependency on his service. And I might know, okay, he's working on it, great. As soon as I see that notification, cool, let me go check it out. So this went ahead and pushed it. It also made a tag, so everything's tagged. And then, of course, if I refresh this guy, we'll see 127, there it is. Now, on the tail end of that, if we go to our deployment repository, we'll see that 43 seconds ago, our little mere mortal CI robot came in here and updated the deployment file for Kubernetes to say use 127. Now, because this repository has its own Travis job, remember, the only responsibility that this one has is to send things out into the world. That's it. It doesn't care if the software was unit tested. It doesn't really care if it passed or not. All it knows is I've got this version and this image. I have my Artifactory. I'm going to grab it, and I'm going to rolling update out into my environment. And so if you look into the Travis file, it's pretty much just doing this apply -f with the deployment. So for those of you that are familiar with Kubernetes, this actually will do a deploy, and on my configuration file, set up for rolling update. It'll just roll it out. And if I go back to here, we'll see that the job is running. We'll probably wrap it up here. I know we're running a little bit tight on time. You're welcome to take a look at these jobs since they are out in the open. And you'll notice if I go back to Kubernetes when this thing finishes deploying. So it's actually spinning up right now, new CPU. So I could go into here. I could see the new replica set that was created 17 seconds ago. And if I want to look at the YAML, I can see that it's 127, right? And so that's the full end-to-end. Like, you just made a brand new deployment. It's going in Kubernetes right now.
Just go to questions.
And that's pretty much it. There's a few quick notes I'll make, and then we'll take a couple questions real fast. One of them is make sure you automate. I want to see robots out there all over GitHub that are doing tons of commits, and they should have followers. That's how many commits they're making and how popular they are. And lean on that automation. Make sure it's working for you.
So there's other information in these slides. They're in swampUP Mere Mortals on GitHub, so you guys can actually see any of the stuff we ended up skipping.
Yeah, and that's pretty much it. We have a few minutes for questions and Q&A. Thank you.
Any questions? You guys are a hard crowd.
And it finished.
So one of the things you can do, so I don't know if you noticed in the deployment, one of the things you probably do in a deployment is after you start rolling out to Kubernetes, you probably should have something saying, hey, does this thing still work? Part of it is part of your plan should be monitoring, is it still running? And part of it should say, is it still working? That's one thing we didn't cover in here. That's one thing we do extensively. Like, we have one of the ways we've leveraged or abused, depending on how you look at it, some of our CI architecture is we run jobs that say, hey, RR network equals open. Those go down all the time, Are my services responding? But on the flip side, if you run them too much, you can actually cause outages all your own.
Yeah. Yeah. Yeah, so if you go back to the repositories, you take a look at these.
For the deployment, correct? So he's asking, where are we storing the build numbers for the deployments? Okay, so we do two things. There's a place in the Gradle one where we call update version. So there's a Gradle.properties that says current version equals 1.2.6. We have a script that just edits that with sed, makes it 1.2.7 or 1.2.8, just increments it. So that's where we store that, and then it ends up in Artifactory. Then there's another script that when we check out that deployment directory, it's also using sed to modify the deployment YAML to change it to that same number it got. So I actually call Gradle print version. There's a little Gradle task I wrote that just prints out version. With Maven, we use the Maven exec plugin to print the POM version. But in both cases, so with Maven, we're not using snapshots. With Gradle, we're not using snapshots. We're just using a hard-coded version number and sed to update it, because it turns out to be easier. Yes.
So that's a rule of thumb, lesson learned here. Have one representation of your version, okay? One canonical source that represents version. I don't care if it's in a Gradle file. I don't care if it's in a POM file. Don't have multiple versions. Don't do that. And if you have a service and that service runs inside of a Docker container, make sure the version in your tag, okay, in your Docker file is the same as that. Pass it in and set it.
If you're aggregating things, use a canonical version, 1.2.0. And then you can actually use X-ray to look into the Docker files, look into the jars and the wars, and continue out that way.
Yes.
Yes. Every time you make a commit, we increment the version.
There's a brand new build on that, right? You did something to trigger a build.
And this had as a side effect. So I have a guy that I work with. He goes in there and there's this cute little thing, build every day. He turns it on, automatically increments the version number. So his version number, no kidding, 1.2.3.500. But he won't let you use those. You can only use 1.2.3 or 1.2.4. He only changes the last number if he made a code change. But he doesn't care about the storage owned by these other guys. And so he's just hell-bent on making sure he fills that up.
Cool. So I think that's it. We're out of time. Like I was saying earlier, feel free to find us, and if you have more questions, let's chat.
Make sure to fill out your feedback forms. Let us know how you liked it. Please play with the stuff. Tell us if it worked out for you. This came from my experience of working at Yahoo and being like, I have these cool tools, and the other people up here on stage, they're all big companies like me, and they have similar cool tools, and we swap ideas. And Jack went off to SADA, and he's like, well, shit, how did you guys do this? How am I supposed to do this? How am I supposed to do this? And I realized, maybe you guys can use some of the things he's learned and be able to leverage it and pick up something from that. Or at least take away cool ideas that, hey, this is how startup did it. This is how Yahoo did it. Well, this is what I'm doing. Maybe I could change what I'm doing.
Cool. Thank you.
Thank you.